Skhulile Ncube. In this lesson is proudly brought to you by the Gauteng Department of Education. Grade 10s, we're continuing with our lesson on the surface area of 3D objects. Right, in this lesson, we're going to look at the surface area and volume of pyramids, cylinders, cones, spheres, and a combination of these objects. You may find that we have an object which is a combination of a cylinder and a cone, or a hemisphere and a cone. We're going to look at those objects. Let's be ready for our lesson, grade 10s. Right, and then our objectives, we're going to calculate the volume and surface areas of pyramids, and then cylinders, cones, spheres, and a combination of these objects. Right, we have done area and volume of prisms, that is our pre-knowledge. Right, as we usually do, let's start with a baseline activity. I'm going to give you 2 minutes for this because it's very easy to do. Right, given the rectangular prism alongside, we have our rectangular prism here. Write 2 formulae. Okay, we discussed this in our previous lesson. Write 2 formulae that may be used to calculate the surface area. I want the 2 of them. And then write the formula used to calculate its volume. So let's have 2 minutes, and then we answer A and B. A, I need 2 answers, and then B, there's only 1 answer. 2 minutes. Right, welcome back, grade 10s. Remember, what did we say about the surface area of a rectangular prism? We have the formula which says 2 times length times breadth. Length times breadth will be which one? Which is this one. Let me choose another color here. Right, it's this one. You see, length times breadth. And then there are 2 rectangles like that, the bottom one and the top one. And then 2 times length times height, length times height is this one. So we have the front one and the one at the back, so that's why we multiply by 2. And then 2 times breadth times height is this one. See that? And then there are 2 of them. Breadth times height, there are 2 of them, so that's why I say 2 times breadth times height. And then the other one we say we find the area of the bases. Let's say this is the base, and then this one is the base. So it's 2 times the area of the bases, and then the lateral faces, it will be the perimeter of the base. Let me just try to pick another color. Let's find that, let's say the perimeter of the base, which is this part, that will be the perimeter of the base, and then times the height of the prism, which is this formula here, 2 times the area of the bases, and then plus perimeter of the base, should be times here, times height of the prism, times height of the prism. This will give you, like this anyway, let's correct this mistake here. Right, so this will give you the surface area of the rectangular prism. Do you remember that? Okay, and then the volume one is very easy. The volume one is very easy. It's just length times breadth times height. And then remember, for a prism, we say it is the area of the base. This may be the area of the base times height of the prism. Okay, right. Now, let's talk about pyramids. What is a pyramid? We have to know these shapes, or we have to know these objects. There's a difference between prisms and pyramids and other shapes. A cone is not a prism. A pyramid is not a prism. A sphere is not a prism. Now, how do we then find the surface area and volume of prism? We're going to, or sort of pyramids, we're going to look at these pyramids, cylinders, spheres, and also cones. Right. A pyramid has a base that is a polygon. A pyramid has a base that is a polygon. You know polygon? It can be a triangle, it can be a square, it can be a rectangle, it can be a pentagon, it can be a hexagon. It can be any polygon that forms the base. Okay? And then we have the faces which are triangles. We have the faces which are triangles. And all of them, all of these faces, they meet at a common vertex called an apex. So we have the triangle, and then these triangles, they form at a common vertex, which we call what? We call an apex. That's a what? That's a pyramid. And then the base can be a polygon, and then the pyramids are named according to the base. It can be a rectangular pyramid, a triangular pyramid, if the base is triangular. See that? Okay, right. So the height of the pyramid, what is it? Remember, grade 10s we're discussing during the lesson. Let's use our WhatsApp line 063-508-1301. Please, let's engage each other during the lesson. The height of the pyramid is the perpendicular distance. Perpendicular distance from where? From the apex. We know what an apex is now. To the base. It is the perpendicular distance from the apex to the base. So this is the perpendicular distance. That's the height of the prism. Not prism, sorry. The height of the pyramid. That's the height of the pyramid. Okay? And then we have the height of these faces which make up this pyramid. The triangular faces, which we call the slant height. The slant height is the altitude or perpendicular height of a face. And then these faces of the pyramid, they are triangular. So the slant height is this one, which is the altitude or perpendicular height of the triangular surface. Okay, face or surface is still same thing. Right, this is the slant height. Okay, right. That's what a pyramid is. That's what a pyramid is. And then I've used here a rectangular pyramid to explain what a pyramid is. Okay, right. Now, if a pyramid, a right pyramid, I just wanted to show you the difference between these, the right pyramid and the oblique pyramid. If a right pyramid and oblique pyramid have the same height and same base, then they also have the same volume. Do you see the difference between these two? The right pyramid, if you draw the height from the apex, it will go straight to the center of the base. But the oblique one, if you draw the height, it is off the center of the base. It's not at what? At the center of what? Of the base there. That's an oblique one. But in our syllabus, we're doing right pyramids, right cones, right cylinders. We don't do the oblique ones, but it's good to know about them. Okay, right. So the surface areas of a right pyramid and an oblique pyramid with the same height and base are not necessarily the same, the surface areas, but the volume is just the same, because volume is what? It will be base area of the base times height sum. So if the bases are the same and the height the same, then the volume will be the same. Right. Now, volume of the pyramid, very easy. It is 1/3 of, remember, times of what? Of the volume of the prism with the same base and height. It is 1/3 times the volume of the prism with the same base and height. What do I mean by that? Let's say we have our pyramid like this, and then we have a prism which has the same base and height as this what? As this pyramid. So we have a prism here. I put the rectangular prism. It has the same height and also the same base. So the volume of this pyramid is inside here. It is 1/3 the volume of this prism that you can see. Do you remember the volume of the prism? How do you find the volume of the prism? It is the area of the base times height, isn't it? So it's area of the base times height. So the volume of the pyramid, it is what? 1/3 times area of the base times height. That's what it means. So let's say you forget about this, you can remember using this. It is 1/3 the area of base times height. Remember, area of base times height is what? Is the volume of the prism. And then the volume of the pyramid is 1/3 times volume of that prism. Okay? So volume of the pyramid is 1/3 times area of the base times height of the pyramid. Let's write this formula. I'll give you 1 minute. Then after that, we'll do an activity. 1 minute. Copy the formula. Just the formula. It's fine. Right, welcome back, grade 10. We're saying the volume of the pyramid is equal to 1/3 times area of the base times height of the pyramid. I hope you have that formula by now. So let's go to the activity. A right pyramid is a square base which is 6 centimeters by 6 centimeters, and each face has a slant height of 5 centimeters. Calculate the height of the pyramid. I want you to calculate the height of the pyramid. I'm going to give you time for that. And then after that, we're going to calculate the volume of the pyramid after getting the height. And then we're going to calculate the total surface area of the pyramid. Let me talk about the total surface area of the pyramid. It is very easy to find the total surface area. It is the area of the base. In this case, our base is a square. And then you find the area of each triangle, okay, of each surface, which is a triangle. And then for this one, this pyramid, all the triangles, the 4 of them, are just the same. They're congruent. They're just the same. So you just find for 1 and then multiply by 4, and then you add the area of the base. Okay, right, we're going to do that. But for now, I want us to find the height of the pyramid. I'm going to give you let me give you 2 minutes to try on your own. After 2 minutes, I'm going to give you a clue, and then after that clue, then we continue for another 2 minutes. Just have 2 minutes to find the height of the pyramid. Right, welcome back, grade 10. I really hope you managed to get the answer. But let's say you did not get the answer. We want this height, the height of the pyramid. Do you see that? And then here, if we join this, what are we forming here? If we join these two like this, what are we forming? We are forming a right-angled triangle. So we're forming a right-angled triangle. And then the slant height here is our hypotenuse. Do you see that? Hypotenuse is the side which is opposite the 90-degree angle or the right angle. So we can find the slant, we have the slant height. So we can find the height here. And then what is this distance from there up to there? Because from there to there is 6 centimeters. So what is the distance from there up to there? It's going to be 3 centimeters. 3 centimeters. Okay, so we have 3 centimeters here and then 5 centimeters for the hypotenuse. Using the Pythagoras theorem, can you find the height of the pyramid? Let me give you 2 minutes. Let's find the height of the pyramid. Right, welcome back, grade 10s. I really hope you managed to find the height of the pyramid. If you check, our hypotenuse is 5, so it's going to be 5 squared is equal to the height squared plus 3 squared. And then the reason here, Pythagoras. Okay, right. You can also do this, like start from here. Just start from here, still fine. S squared is equal to 5 squared minus 3 squared. And then write your reason, Pythagoras. And then it means height is going to be the square root of 5 squared minus 3 squared, which is equal to 4. So the height of the pyramid is 4 centimeters. Remember this Pythagoras triplet. 3, 4, 5. Always remember this. 3 is to 4 is to 5. Okay? All right. We have 5 here and 3 there. So the missing one is 4. Okay? So now we have the height of what? Of the pyramid. Let's use our formula. Remember I said you must copy the formula. Let's use our formula to find the volume of the pyramid. You remember? Volume of the pyramid is 1/3 times area of the base times height of the prism. Let's try to do that in 1 minute. Right, welcome back. So the volume of the pyramid, we say volume, let me just write V for volume, is equal to 1/3 times base, area of base, area of base times height of the prism, and then it's going to be volume is equal to 1/3, and then area of the base is 6 times 6, so 6 times 6, then times height of the prism, which is 4. Then you can put this in the calculator, okay? Or so it's going to be what? This one can be, even without a calculator, 3 into 3, 1, 3 into 6 is 2, 2 times 6 is 12, 12 times 4 is 48. So volume is 48 cubic centimeters, okay? All right, let me show you the surface area. So that we can move on to the other 3D objects. All right, surface area now, we need to find the surface area of the base. What will be the surface area of the base? Is going to be 6 times 6. Let's start by saying area of base is equal to 6 times 6, which is 36 square centimeters, right? And then for the triangles, we just find for one triangle. If that be enough. This one is area of base times, it's half times base times height. Half times base times height. But there are 4 of them. So area of triangle. Let's just say area of triangles. It's going to be 4 times, then half times base. Our base is 6. This is the base here. And then height of the triangle is 5. Half times base times height, and then what we get, this is like 2 into 2, 1, 2 into 6, 3. So in the bracket we have 15. 15 times 4, that is 60. So 60 square centimeters. Now the total surface area now of the whole pyramid, total surface area, let's say SA for surface area, is equal to 36 plus 60, which is 96 square centimeters. Okay, all right, let me give you 1 minute to write your notes, then we move on to the next question. Let's save our notes. Right, welcome back, Cretans. Let's have our next question. It's still on pyramids, and then after that we'll move on to cylinders. Right, let me explain this one so that we can move to cylinders after that. So a right prism is a rectangular base with dimensions of 10 meters by 18 meters, and the height of the prism there, the height of the pyramid, sorry, I'm confusing these two. The height of the pyramid is 12 meters. Calculate the volume of the pyramid. And then slant height of the faces. And then after that, total surface area of the pyramid. Okay, let me explain this. Right? Volume of the pyramid, we know how to find the volume of the pyramid. This one is going to be easy because it is the area of the base. 1/3 of the area of the base times height of the prism. So it's going to be volume is equal to 1/3 of the area of the base is 10 times 18. 10 times 18, that's the area of the base. And then times the height of the prism, which is 12. Okay? And then you can put this in the calculator. You will get that volume is equal to 720 cubic meters. That's the volume there. Okay? All right. Let's move on to B. B says, calculate the slant height of the faces. So now, the slant heights are going to be different, but because if you check, these triangles are not the same. Let me just name the vertices here. This is A, then B, C, D, E. Right, we have triangle ABC. Do you see triangle ABC? It is the same as triangle AED. Okay, but it is not the same as triangle ACD. ACD will be the same as ABE. Okay, now we are going to find the slant height for triangle ABC, this one, which is different from the slant height of triangle ACD. So let's start by finding this one, right? This is 12, and then the distance from there after there will be 9, because this CD there is 18. So half of 18 there is 9. For right pyramids, remember, this height is at the center. So it means the distance there is 9, half of 18. Right? So we can find the slant height. Let's call it slant height for ABC. Okay, which is the hypotenuse. So slant height ABC squared is equal to 12 squared plus 9 squared. That's Pythagoras. Okay, right, and then we square root both sides. Slant height of triangle ABC will be the square root of 12 squared plus 9 squared. What is square root of 12 squared plus 9 squared? Is going to be 15 meters. So this means this is 15 meters. Okay, and then let's look at triangle ACD. This one, ACD. What is the slant height here? Okay, this distance is going to be half of 10, because this is the center. So it means this is half of 10, it means this is 5. And then the height is still the same, which is 12. So we can find this slant height, which is the hypotenuse there. So slant height of triangle ACD squared is equal to 12 squared plus 5 squared. And then slant height ACD is equal to square root of 12 squared plus 5 squared, which is 13 meters. So this distance here, the slant height here, is 13 meters. Okay, all right. So that's what we're supposed to do there. And then let's move on to the next one, which is C. You can just listen here and write short notes if you can. And then C, we're supposed to find the total surface area of the pyramid. So we can easily find the surface area of the base, which is 10 times 18, right? Surface area of base is equal to 10 times 18, which is 180 square meters. Then let's have our triangle ABC. Right, triangle ABC and triangle AET are the same. So surface area for triangle ABC plus triangle AET, okay, those two are the same. It's going to be 2 times. And then we say the slant height of this triangle, we got 15, remember, 15 meters from the previous question. So it's going to be half times base times height, which is half. Then the base is 10, this 10, and then times height, which is 15, right? And then you can put this in the calculator. What do you get? You get what? 2 times half times, it should be 150. This should give us 150. All right, 150. Okay, because 2 and half will give us 1. 10 times 15 is 150. Then let's look at the front one now. Triangle ACD and triangle ABE. Surface area of triangle ACD plus triangle ABE is going to be 2 times, and then we say the slant height of this face is what? We got 13, so it's going to be half times base. Our base is 18, and then 18, and then times 13. All right, 18 times 13, what is it? Let me calculate here. 18 times 13, 234. Because this 2 and this 2 will give us 1. So you remain with 234, right? And then you add 180 plus 150 plus 234. Right, that's the total surface area. Total surface area is equal to 180 for the base, plus 150 for these two, and then plus 234 for these two triangles. Then this should give you 564 square meters. Okay, so that's the surface area of the pyramids. Okay, now let's go to the cylinders. Cylinders can be oblique, just like the pyramids. If a right cylinder and an oblique cylinder have the same base and height, then they will have the same volume. Like these two, if they have the same base and height, then they have the same volume. Okay, this is the right cylinder, center to center. You see that? Okay, right? And then a right cylinder has two parallel circular bases. Two parallel circular bases, this one and this one. And a lateral face that when unrolled, this blue part, is it blue? Yes, blue. That's the lateral face around the cylinder. If it is unrolled, if it's opened up, it becomes a rectangle. It becomes a rectangle like this, which has a length that is equivalent to the circumference of the base. So this length from there up to there is equivalent to the circumference of the base. Remember, circle is 2 pi r. Okay, So this length from there up to there is 2 pi r. And breadth, that is equivalent to the height of the cylinder. This distance from there up to there, it is equivalent to this, so which is height. And then remember, how do you find the area of a rectangle? It is length times breadth. So meaning that this is 2 pi r times height. Let me use capital letter H for the height of the prism, of the cylinder in this case. Okay, so this blue part, this is how we find the area. And then how do you find the area of a circle? It's pi r squared. Pi r squared. And then we have how many pi r squared? We have 2 of them. So it's going to be 2 times pi r squared plus this. That's how you find the surface area of a cylinder. Okay, so it's going to be 2 times pi r squared, which is this, and then 2 pi r h, which is this. Okay, right, just wait, I'm going to give you time to write your formula. And then the surface area, sorry, volume is still area of the base times height of the, remember, area of the base times height of the prism. We're using that. So it's area of the base, which is a circle, times height of the cylinder. So it's going to be pi r squared times height. That's how you find the volume. Okay, please just 1 minute to write this and this. 1 minute. Right, welcome back, grade 10. Now I want you to use these two to do the following activity. Right, we're given a cylinder with a diameter of 7 centimeters and a height of 20 centimeters. Let's calculate the volume of the cylinder and then total surface area of the cylinder. Let's do this in 4 minutes. 4 minutes. Right, welcome back, great chance. We said that the volume of the cylinder, let me write V, is equal to pi r squared times height of the cylinder. Right, pi r squared. So it means here we need to find radius, not diameter. We cannot use diameter, we need radius. Radius is half of diameter, so it means radius is 3,5. Okay, so it becomes volume is equal to pi times what? Times 3,5 squared, and then times height of the prism, which is 20. All right, and then what you get, volume is equal to 769,6902,001. But says 1 decimal place here, so it becomes 769,7. We're calculating not volume, so it's cubic centimeters, okay? Right, you have to use pi in the calculator. Let me show you how to use the calculator. So you go to your calculator, and then you press shift, and then in the last part there, you see your pi there, and then that's your pi. And then we have our 3,5 squared. You enter your 3,5 squared, and then times the height of the cylinder. The height of the cylinder is 20, and then equals. And then you can press SD, you see, press SD to get your decimal fraction there. That's the answer there, okay? And then just write your answer and make sure you round off correctly. Okay, that's how you use the calculator. And then use the pi in the calculator. Then B, the total surface area of the cylinder. So surface area is equal to 2 pi r squared, which is for the two circles. Okay, and then plus 2 pi r times height, which is for the lateral face. When unrolled, remember we talked about that. And then we can just substitute here, and then you can use your calculator. Now we know how to use your calculator. So 2 times pi radius squared 3,5 squared plus, and then 2 times pi, use your pi in the calculator, radius 3,5, and then the height is 20. Put this in the calculator, we get 516,7919915, and then 1 decimal place, you get 516,8 square centimeters, because that's area. Okay, right, that is that on the cylinder. Let's discuss the cone. We have 15 minutes roughly. Let's discuss the cone. Right, a right cone has a circular base. It has a circular base. You know a cone, like an ice cream cone, shaped like that. Okay, right, a right cone is a circular base and a lateral face. This is the circular base. Right, and then the lateral face, when unrolled, this face, which is the lateral face, forms a sector of a circle. Okay, I'll give you the formula. Don't stress about how to find the surface area of a sector. I'll just give you a formula straight away. Right, so this is the lateral face, and then this is the height of the cone from the apex to the center of the base, and then we have the radius there. Okay, right, so this is the sector of this circle, which is formed by this lateral face, and then we have the base, which is a circle. So the surface area of the cone will be the area of the circle, pi r squared, plus the area of the sector of a circle. Okay, and then to find the area of a sector is very easy. I'll just show you now. Right, and then we have this. We say this is radius. This is the height of the circle, and then we have the slant height. The slant height. So that's what we use for our area of the lateral face. Okay, so now surface area is going to be pi r squared. This is for the circle, which is the base, and then pi times radius times slant height. That gives you the sector of the circle. Okay, pi times radius times slant height. Okay, right, so write this formula. Oh, we need to just the volume. Let me give you the volume one, then we write both of them. Right, the volume of the cone, just like the pyramid, Remember, pyramid set is 1/3 times volume of the prism that is the same base and same height. But now for the cone, it is 1/3 times volume of the cylinder with the same base and same height, like this one. If you have a cylinder like that, same base and same height with the cone, then the volume of the cone is 1/3 the volume of that cylinder. Okay, so remember how we find the volume of the cylinder is pi r squared times height, pi r squared times height. So it means the volume of the cone is going to be 1/3 times pi r squared times height, which is this. Okay, so this is the surface area, this is the volume. Please write these two down before I give you an activity. Let's try. 1 minute. Right, welcome back. I want us to try this. The volume of a cone is 12 pi cubic centimeters and its height is 4 centimeters. Calculate the radius of the base, calculate the slant height of the cone, and then the total surface area of the cone. Let me give you 3 minutes, and then after 3 minutes we're going to discuss. Let's try. Right, welcome back, returns. Let's discuss these three. Right, we are given the volume of a cone, and then we know the formula for finding the volume of a cone is said volume is equal to one third times pi r squared times height. Okay, so we want to find the radius. So we have height, we have pi, we have volume. So let's say 12 pi, which is this, is equal to 1 over 3 pi r squared height. And then we can divide both sides by pi, pi divided by pi, so they cancel each other out if we divide both sides by pi. All right, what else can we do? We can multiply both sides by what? By 3. We can multiply both sides by 3. Oh, the height we have, right? Let's substitute. This is 4. Okay. We can multiply both sides by 3 to get rid of the denominator. We get 36 is equal to 4 times r squared. And then we divide both sides by 4 to get rid of the 4. This side becomes 9 is equal to r squared. And then here we can use difference of two squares, or we square root both sides. We get that r is equal to positive or negative 3. But radius is distance, therefore radius is equal to 3. Cannot be negative, right? So it's 3 centimeters. So radius is 3 centimeters here. Okay, right. So now the second one, B, the slant height. Now we have 3 centimeters. We did something like this. The slant height is the hypotenuse. Okay, so slant height squared is equal to 3 squared plus 4 squared because of Pythagoras. And then this is slant height. Then slant height is equal to the square root of 3 squared plus 4 squared, which is 9 plus 16, which is 25. Square root of 25 is what? It's 5. So slant height is equal to 5 centimeters. So this is 5 centimeters. Okay, right. And then the last one, the total surface area of the cone. Remember I said surface area of the cone is equal to the area of the circle, which is pi r squared, plus the area of the sector of the circle, this lateral face, which is pi times radius times slant height. Okay, so it becomes pi, radius is 3 squared plus pi, and then radius is 3, and then slant height is 5. Then just put this in the calculator. You get your 75,39822, goes on like that. 2 decimal places, 75,40 square centimeters. That's your answer there. Okay, right. We're left with 3 minutes. I want us to discuss the sphere. We won't do calculations, we just discuss, and then after that, we're going to go straight to our homework. Let's discuss the sphere. But a sphere is a symmetrical ball with all points on the surface of the sphere being equidistant from the center. All the points equidistant from the center. The surface area of a sphere is 4 times pi times radius squared. And then the volume of a sphere is 4 over 3 times pi times radius cubed. Okay, let me give you just 1 minute to write these two. The surface area of a sphere and the volume of a sphere. Let's try to do that. Right, welcome back. So now that's the sphere, and then a hemisphere is half of a sphere. A hemisphere, half of a sphere. Like we talk, some of you are doing geography, we talk of the southern hemisphere and the northern hemisphere. That's the Earth, divided into two equal half spheres. So if we divide this sphere like this, we have a hemisphere, two of them, that combine and make a sphere. Right, so volume of a sphere or hemisphere is half the volume of a sphere. It's very easy. Half the volume of a sphere. Whether the hemisphere is closed or open, the volume does not change. Half of the volume of the hemisphere, of the sphere, sorry. And then a sphere may be closed or open. What do I mean by that? It means when it's closed, this circle is also there. This circle is also there. Right, just imagine, think of the tennis ball. Inside the tennis ball, there's nothing. But if you cut half of it, it will remain open inside. There's nothing on top, isn't it? It's going to remain open. That will be an open hemisphere. But if you cut an orange, for example, that top part will be there. So that will be a closed hemisphere. So for a closed hemisphere, the surface area is half of the hemisphere plus this circle, the top part. Pi r squared is for the circle, the top part. But volume does not change. It's just half of the volume of the sphere. It does not change. Okay? Right? And then just take note of that, and then I'm rushing to the open one, then we conclude our lesson. And then the open one, like this, is nothing there. So it's just half, the surface area is half the surface area of the sphere. Just that, because the pi r squared is not there, so we don't add it there. Okay, if you check, the volume is still the same, does not change. Right, let's take a short break, and then after break we're going to summarize all this.
The road to success is to commit to yourself. In order for you to become who you want to become as a student, you need to commit to reading your books, to studying, to bettering yourself. I know it's not going to be easy. Actually, no one said it's going to be easy. But if you put in the work, the results will show in your life. Tap into your power. Sometimes you will feel like putting away your books, and not reading as much as you're supposed to be. But I want you to commit, because through commitment, there is infinite power.
Right, welcome back, grade 10s. Let's summarize our lesson. We say the surface area of a cylinder.
The road
2 pi
to
r
success.
squared, which is 2 circles, plus 2 pi r times height of the cylinder, which is the lateral face. Okay? And then the volume of a cylinder, area of the base, which is the circle, times height of the cylinder. Area of the base times height of the cylinder. That's the volume of a cylinder. Surface area of a sphere, remember, 4 times pi times r squared. And then volume of a sphere is 4/3 times pi times the radius squared. Okay? And then surface area of a pyramid is area of the base plus the area of all the triangular faces. And then volume of a pyramid is 1/3 the area of the base times height of the pyramid. Then surface area of a cone is pi r s, which is the sector, plus the area of the circle. Volume of a cone is 1/3 pi r squared times height of the cone. Okay, right, that's what we have done today, grade 10s. We are done with the surface area and volume of what? Of 2D shapes of 3D objects. In our next lesson, we're going to be doing the linear number patterns. Let's meet next week on Thursday. Every Thursday, we're doing our mathematics at 9 a.m. Goodbye, grade 10s.